Today we are going to continue our lesson about mole concept for Part D. Learning outcomes. At the end of this topic, students should be able to define for each of the following concentration measurements: molarity, molality, mole fraction, percentage by mass, and percentage by volume. Concentration units. When an amount of solute dissolves completely in a solvent, it will form a homogeneous mixture called solution. The common terms that you have to understand before we go further are solute. Solute is the substance being dissolved and present in the smaller amount. Solvent. Solvent is the substance doing solving and present in the larger amount. Solution. Solution is a homogeneous mixture of two or more substances that form when amount of solute dissolves completely in a solvent. Concentration. Concentration is the amount of solute present in a given quantity of solvent in a solution. Have a look at example 1. We have water and add with sugar, we will form a sugar solution. So what is solute and solvent? Solute is a sugar while solvent is water. Expression of concentration. There are several ways to represent concentration of a solution. Molar concentration or molarity, molar concentration or molality, percentage by mass, percentage by volume, and mole fraction. The first one is molarity. The symbol is capital letter M. Molarity is the number of mole of solute dissolved in 1 liter of solution. The unit that we can use is mole per liter or mole per decimeter cube or molar. The formula for molarity equals to mole of solute in mole divided by volume of solution in liter. Example 2. Given 1.46 molar glucose or 1.46 mole per liter glucose, it means that it has 1.46 mole of glucose which is solute dissolved in 1 liter of the solution. Next is molality. Molality is the number of mole of solute per 1 kilogram of solvent in a solution. The unit is mole per kilogram or molal or small letter m. Formula for molarity is equals to mole of solute in mole divided by mass of solvent in kilogram. Mass of solution is equal to mass of solute plus mass of solvent. But volume of solution is not equal to the volume of solvent. Mole fraction. The symbol is capital letter X. Mole fraction is the ratio of the number of moles of one component to the total of number of moles present. The formula for mole fraction of A is equal to mole A divided by mole total, where mole A is equal to the number of mole of component A in the mixture, while N total equals to total number of moles in all components in the mixture. If a solution containing A, B, and C, mole fraction of A equals to mole A divided by mole A plus mole B plus mole C. Or we can use mole A divided by mole total. Remember guys, no unit for mole fraction. Mole fraction always smaller than 1.000 and total mole fraction in mixture equals to 1.000. Percentage by mass. Percentage by mass is the ratio of the mass of solute to the mass of the solution multiplied by 100. Here the formula. Percentage by mass equals to mass of solute in gram divided by mass of solution in gram multiplied by 100. Or we can use mass of solute in gram divided by mass of solute plus mass of solvent in gram multiplied by 100. Here, mass of solution is equal to mass of solute plus mass of solvent. Let me look at example 3. Given that 10% by mass of sodium hydroxide in the solution. According to the formula percentage by mass, the mass of solute in gram divided by mass of solution in gram multiplied by 100. It shows that 10 grams of sodium hydroxide dissolved in 100 grams of solution, or 10 grams of sodium hydroxide dissolved in 90 grams of solvent, which is water. Percentage by volume. Percentage by volume is the ratio of the volume of a solute to the volume of the solution multiplied by 100. The formula for percentage by volume is volume of solute divided by volume of solution multiplied by 100. It most often used for liquids and gas. Helpful tips. For questions that give concentration and density, we can make assumptions based on concentration. For molarity, since the formula involves the volume of solution in liter, hence we can assume volume of solution is equal to 1 liter. For molality, since the formula involves the mass of solvent in kilogram, we can assume mass of solvent equals to 1 kilogram. For percentage by mass, since the formula involves the mass of solution in gram, we can assume mass solution is equal to 100 gram. And the last one, percentage by volume, since the formula involves the volume of solution, we can assume volume of solution equals to 100 milliliter. Let me try this exercise. Given 0.05 mol zinc powder is added to 10 milliliter hydrochloric acid to form a zinc chloride solution. The question is, define the molarity of zinc chloride solution. You are given 30 seconds to choose the correct definition for the situation.
Like a bird on a tree, I'm just sitting here. I got time, it's clear to see. From up here, the world seems small. We can sit
Okay, the answer is B. 0.05 0.5
It's so
mol of zinc
beautiful.
dissolved in
You and
0.01
me.
liter zinc chloride solution.